In trigonometry, we often need to be able to solve our right triangles. And so for right triangles, we can use given information of either angles or sides to find missing pieces of information, therefore solving for the right triangle. So in order to solve for right triangles, we can use different tools, such as the Pythagorean theorem, but we can only use the Pythagorean theorem when two sides of a triangle are given. We can also use the definitions of our trigonometric functions. We can also use special angles because special angles have special ratios. And then finally, we can use inverse trigonometric functions. And remember, inverse trigonometric functions are used when we're trying to find angles, not sides. So for our first example of solving a right triangle, we are given A equals 17.2, C is equal to 28.1, and then C is equal to 90 degrees. So the first thing I want to make sure we understand is that A is a side, and we know this for two reasons. One, A is given in lowercase, and then secondly, 17.2 does not have a degree symbol. That is the same for C equals 28.1. Now, since angle C is 90 degrees, that means side C is our hypotenuse. Therefore, it is the longest side. So let's figure out what we're actually missing. So if we have side A and the hypotenuse C, that means we're missing the other leg, which is B. We were given angle C is 90 degrees, but we do not know what angle A is, nor do we know what angle B is. So that is the information that we need to find. Now, a technique for solving right triangles that will always be helpful is try to draw what you don't know. Now, we don't know if side B is less than side A or greater than side A. So we're just going to draw a triangle and place our given information so that we also understand what is missing. So we do not know what angle A is, but we know that side A is 17.2. We do not know what angle B is, nor do we know side B. We know angle C is 90 degrees, and we know the hypotenuse is 28.1. Now, as we said up above, we can use the Pythagorean theorem in order to find the third side. So a squared plus b squared equals c squared, but we have a squared. So we have a squared plus b squared equals c squared. And in order to solve for b, we need to subtract 17.2 squared and then also take the square root of that result. So subtract and take the square root. Now, I really do not care what 28.1 squared is, nor do I care what 17.2 squared is. I'm simply using those values to find side B. So B is equal to the square root of 28.1 squared minus 17.2 squared. And when we substitute that into our calculator, we get an approximate value, and notice we're asked to round this to the nearest tenth, of 22.2. Now, I do want you to notice that side B is greater, isn't it, than side A, which means angle B will have to be greater than angle A. So those are the two things we have left to find. Now, the way in which we're going to do this is by using our given information. We are not going to use 22.2 at all for three reasons. One, it wasn't given to us. Secondly, it might be wrong. Couldn't we easily have put a value into our calculator incorrectly, therefore it's wrong? We don't want to use a wrong value to go on and find more values. And then third reason we don't want to use 22.2 is because it is not exact, it is approximate. So we can only use side A and side C. Now let's focus on angle A. In relation to angle A, what do we have? So in relation to angle A, we have the opposite side and we have the hypotenuse. So that means we're going to use sine. So sine of angle A is equal to the opposite side divided by the hypotenuse. And now remember, we're trying to find an angle, so we're going to use inverse trigonometric functions. So we need to get rid of the sine by using sine inverse. So A is equal to sine inverse of this ratio. And now making sure my calculator is in degree mode, we're going to input sine inverse of 17.2 divided by 28.1. And so rounding to the nearest tenth, my angle is approximately 37.7 degrees. Now, I'm not going to use angle A to find angle B. I'm going to do the same as before. I'm going to focus on angle B, and in relation to angle B, what do we have? So in relation to angle B, we have side A, which is the adjacent side. It's next to angle B, and we have the hypotenuse. So with adjacent and hypotenuse, that means we're going to be using cosine. Because cosine of angle B is equal to the adjacent side over the hypotenuse. And notice that's the same ratio, but now when we use our inverse trigonometric function of cosine, when we substitute that into our calculator, it's going to give us a different angle. So input cosine inverse of 17.2 divided by 28.1. And when we do that in our calculator, we will get 52.3 degrees, rounding to the nearest tenth. And then I do want you to note A plus B. What happens when you add those two together? So if we take A, 37.7 degrees, and add it to 52.3 degrees, that will equal 90 degrees, which is a really nice check, because if angle C is 90 degrees, then angles A and B have to be complementary. They must add to 90 degrees. So you have two questions here. For right triangle ABC, we are given that side A is 7.6 and side B is 18.5. And this is a right triangle with angle C equals 90 degrees. And you are asked to find angle A to the nearest tenth. And then second question, you are asked to find side C to the nearest tenth. For our next example, we're actually going to be using our special angles here. and we're going to find the exact lengths of x and y. But in order to do that, I need to give you some more information on this triangle. So first, I am telling you that this left triangle is a right triangle with this angle at 90 degrees. This angle is special. It is 30 degrees. Now, our right triangle is also a right triangle, but this angle is 60 degrees. Now, they have a shared side, and that is side X. And then we have a side of the triangle on the right side, Y. And then we have a known side of the triangle on the left side, which is 50 feet. And so you are asked to find X and Y. Now, notice for the triangle on the right-hand side, the only information we know about it is that it is a triangle with the bottom angle to the right of 60 degrees, but we do not have any side lengths. So we're going to have to start with the triangle on the left. So 30 degrees is a special angle. And let's take a moment to see what we don't have, but more importantly, what do we have? So opposite the 30-degree angle is X, but we have 50 feet, and that is a known side, but it's not just a side, it's the hypotenuse, isn't it? So notice for 30 degrees, we don't have the opposite side, but we do have the hypotenuse. We're going to use sine. So sine of 30 degrees. You can say two different things about that. Sine of 30 degrees, that's a ratio that you should know. Sine of 30 degrees, no matter the size of the triangle, will always have a ratio of opposite side of 1 and hypotenuse of 2. But then using our specific triangle, sine of 30 degrees, the opposite side is X, but the hypotenuse is given as 50. Now, sine of 30 degrees is being used twice. So if sine of 30 degrees is equal to 1/2 and it is equal to x over 50, we can actually set those equal to each other and solve for our unknown. And so if I cross multiply, I get 2x equals 50, which means x is equal to 25. And now we know x, and x is a shared side for both the left triangle and the triangle on the right-hand side. So now we know something about this triangle, so we can actually solve for y. So now we know x is 25, and notice x is the side opposite our 60-degree angle, and y is the hypotenuse of this triangle. So we can use sine again. So sine of 60 degrees, that's a special ratio as well. And for sine of 60 degrees, it always has the ratio of radical 3 over 2. But for our triangle, sine of 60 degrees is x, but we just found that, which is 25, over y. Setting these two equal to each other, we have radical 3 over 2 equals 25 over y, and cross multiplying, we have 2 times 25, which is 50, equals radical 3 times y. So 50 equals y times the square root of 3. And then dividing to solve for y, y is equal to 50 divided by the square root of 3. And now we need to rationalize. And so y is equal to 50 times the square root of 3. Oops, and I forgot my radical symbol there. And radical 3 times radical 3 is radical 9, also known as 3. So we were able to use our special ratios to solve for both x and y as directed. Your last question for today, and I need to give you a little bit of information here. This is an isosceles right triangle, and an isosceles right triangle means two of the sides are the same, therefore two of the angles are the same. Right triangle means we have a right angle. So I'm going to label our right angle C. A and B, because this is isosceles, both have to be 45 degrees. And you are told that side A is 12, and you are asked to find the exact value of the hypotenuse.